Hello everyone, I welcomes all of you to this lecture. In previous lecture, we have seen need of the test signals, and we have seen different types of a test signal which can be applied to test the system's response in a control system. So we have seen step input, ramp input, then after that we have seen parabolic input. So different types of different types of test signals we have studied. Okay, and we have also seen the Laplace transform of that particular test signal. Okay, so after that we have seen what do we mean by pole, what do we mean by zero, what is the procedure for that also we have seen. If you don't know about that, then you can refer my previous video which is posted in this YouTube channel. So you may have given one simple transfer function, and with the help of that transfer function you have to calculate poles and the zeros of that transfer function, and after that we have to represent that poles and zero on one plot that is called as a pole zero plot, and it is basically placed on S plane. Okay, so let us see what do you mean by this pole zero plot, and how to represent that zeros and poles on that plane that we have to see here. Okay, so if you see the pole zero plot, the diagram obtained by locating all poles and zeros of a transfer function in the S plane is called as a poles and zeros plot. Okay, now we have seen how to calculate poles, how to calculate zeros, okay, by putting different values in that equation. Okay, how to consider numerator, how to consider denominator, that also we have seen. Okay, so after that we have seen how to calculate this poles zeros and how to place this poles and zero and represent these poles and zeros on a S plane. Okay, so the diagram obtained by locating all the poles and zeros of a transfer function in the S plane is called as a pole zero plot. Okay, so what do you mean by this S plane that we have to see here? The S plane has a two axes, so it may be real or it may be imaginary. Okay, so if you see this S plane, okay, so there are two axes, X axis and Y axis is there, and these axes are real and imaginary. Okay, so since S is equal to sigma plus j omega, so this is a equation, sigma plus j omega, and the axis X axis stands for the real axis, shows the value of a sigma. Okay, so if you see this equation, S is equal to sigma plus j omega, here sigma represents the real value and the j omega represents the imaginary value. So if you see any equation, it may be combination of these two values. Okay, so either it may be having real values, or we can say imaginary values, or combination of these both. Okay, so here we have taken this combination, S is equal to sigma plus j omega. So X axis stands for real axis and it shows the value of a sigma, which is a real value. Okay, and as discussed earlier, j omega is representing imaginary values, so that's why the Y axis stands for j omega here, and it is used to represent imaginary values or imaginary axis, we can say. Okay, so I think you know what do you mean by real values, what do you mean by imaginary values. You may have studied that in maths first year or in 11th 12th, I think. It's okay, I think you are aware about this real value and imaginary values. Okay, so while solving the equation, you also come to know that what do you mean by real value and imaginary value. Okay, so where there is a j, it can be called as imaginary, and the real values can be positive, negative. Okay, or we will see after, don't worry about that. Okay, so let us see the pole zero plot that we have seen earlier in previous example, just for revision purpose. See here, so this is the pole zero plot where poles and zero are represented on a S plane. Okay, so if you see this axis, this is your real axis, which is represented by sigma, and if you see this is a Y axis, which is represented by j omega. Okay, if you see the previous example, we were not having the imaginary values, we were having only real values. Okay, so that's why here this plane represents only real values. Okay, so we will see the example based upon real imaginary values as well as real values also. so don't worry about that. So just see here, this is a sigma which is representing the real values, and this is the j omega, that is y-axis, which is representing the imaginary values. So right now we don't have any imaginary values in our equation. So see here how the zeros and poles are represented. So the poles are represented by this cross symbol, or it looks like a multiplication symbol in mathematics, and the small circles or small dots, we can say that this can be used to represent the zeros in the equation. Okay, so now it is clear to you that the small circles are used to represent the zeros and the cross are used to represent the poles in the system. This is the x-axis, real values. This is the imaginary axis, that is imaginary values. Okay, so sigma is real value, j omega is imaginary value. Okay, so let us see the example based upon this, so that you can clearly understand what do you mean by real values and imaginary values. So before that, let us see what do we mean by characteristics equation. So I think this point we have discussed earlier, then again we will see what do we mean by characteristics equation. So if you see the definition of this, the equation obtained by equating the denominator polynomial of a transfer function to 0 is called as a characteristics equation. So this is very simple. If you have given any, suppose if you have given any transfer function, then just take the denominator of that transfer function and equate that to 0, then it will become your characteristic equation. So in mathematical form, if you see, it will look like this: s raised to n plus a n minus 1 into s raised to n minus 1 plus a n minus 2 into s n minus 2 s raised to n minus 2 plus dot dot dot, it will be up to a n. Okay, so I think it will be difficult for you. Okay, so if we take an example, then you will understand. Okay, so don't worry about that, it is just a mathematical representation of that characteristics equation. Let us see next example, in which we have to find 4 values. We have to calculate 4 values here. The first we have to calculate the poles, then zeros, then we have to draw the pole zero plot based upon this poles value and zeros values, and the last one is very simple, that is we have to see the characteristics equation. Okay, now here you have to consider one important thing, is that you must know how to make a factor of given equation. You must know that. Okay, that is very important. Okay, so when there is imaginary values present in the equation, then it will be little bit difficult for you to calculate that values, but if you are good in maths, then it will be very simple for you. Okay, but there is no any so much difficult maths here. It is very simple. Again, I am repeating. Okay, so anyone can solve here, no doubt. So for the given transfer function, the transfer function is given like this. You have to calculate these 4 values. So if you see the transfer function, I will repeat here: k into s plus 6 in bracket, okay, divided by s into first bracket s plus 2 into second bracket s plus 5 into third bracket s square plus 7s plus 12. Okay, now the first thing that we have to do is here is that we have to find the value of poles. Okay, so how to find a value of poles? That you know, the poles can be obtained by equating denominator with the 0. Okay, so this is a numerator and this below part is denominator. So we have to equate this denominator with the 0, and after that we have to find the value of the pole. So how we are going to find the value of a pole? So we have to make this equation, denominator equation, 0. So we have to put the values in this equation in a such a way that we have to equate this denominator to 0, so that the equations reaches to infinity. Okay, so anything divided by 0 will be infinite, that you know. So that's why we have to keep the value of the s in a such a way that this equation will become a 0. So let us see how to obtain that. See here we have so many choices. Okay, so here the single value is there, then first bracket, second bracket, third bracket is there. So we have so many choices here. So let us see which choices are simple first, and then we will move towards the next part. But we have to see each and every choice. Okay, so then only we can our answer will be correct, we can find that poles correctly. Okay, so let us see the first choice, that is how to make this whole equation as a 0, left side as a 0. How to make this as 0? This whole thing is multiplied here, so that's why I think if I put s is equal to 0, this whole thing will become a 0, or this denominator will become 0 and the equation will become infinite. So this is my first choice, that s can be 0. Okay, so this is my first pole that I have located here or calculated. We will locate afterwards on a graph. Okay, so second choice is that I can make this first paragraph as a 0. So how to make this first paragraph as a 0? We have to put s value as a -2, because -2 plus 2 will become a 0, gets cancelled. Okay, so that's why if you see here, I can put s plus 2 is equal to 0, means this brackets value I can put as a 0. Means what? In other words, if 2 becomes if this 2 is passed to this right side, then what will happen here? S will be what? -2. Similarly, the third choice is that I can make this paragraph as a 0, this para as a 0. So s plus 5 is equal to 0. So I can put s plus 5 is equal to 0, means what? I have to pass this 5 to right side, so it will become s is equal to -5. So just 3 possibilities we have calculated here. I can put s is equal to 0, I can put s is equal to -2, and I can put s is equal to -5. So is it over? No, it is not over yet, because we have to put this value also as a 0, so that this equation will become 0 and the transfer function will become infinite. But now you must know how to make a factor of this. Okay, so let us see how to solve this. Now this third choice I have to make as a 0. Okay, so if you see here, s square plus 7s plus 12 is equal to, here the factors are s plus 3, this first bracket, and second bracket is s plus 4. Okay, so again I think it is very simple, because if you multiply this inside, you will get this equation. Let us check that. If you multiply this s with this first s, it will become s square, then s with this 4, it will become 4s. After that you have to multiply this 3 with s, and after that we have to multiply it with this 3 with 4. Okay, means what? Again, if you don't know about this, let us see how to multiply this. Multiply this first element with each and every element of the second para, and after that take second element and multiply with each and every. Okay, so s square plus 3s plus 4s plus 12 we are getting. So 3s plus 4s is equal to 7s, and ultimately we are getting a equation like this, s square plus 7s plus 12. Okay, so this is the simple way of solution. Okay, so just you have to cross check that after multiplying this, if you are not having a confidence. Okay, so after that you can check this, but I think it is very simple mathematics. Okay, so here I have again 2 choices after substitution of these values here. So this para can be replaced by, with these 2 paras. So s plus 3 is equal to 0 I can put, so either I can put s plus 4 is equal to 0. Okay, so again 2 new values we have got here, s is equal to -3 and s is equal to -4. Okay, so now see the value of poles. The poles are s is equal to 0, or s is equal to -2, or s is equal to -3, or s is equal to -4, or s is equal to -5. Okay, so these things we have seen here. Means what? You can put any value here, it will let you this denominator to 0 and this transfer function to infinity. That is the definition of a pole. Okay, so similarly, based upon these steps, we have calculated the poles. So how many poles we have got here? 1 2 3 4 5. Okay, and after that we have to calculate the zeros, and after that we will draw the pole 0 plot on that S plane, which can be called as a pole 0 plot. Okay, now if you see how to calculate a 0, then you know that we have to just take the here the zeros can be obtained by equating the numerator with the 0. Okay, so the k is a constant here, so that's why we have to take s plus 6 and s plus 6 is equal to 0, so s is equal to minus 6. So though there is only one 0, that is s is equal to minus 6. So we have discussed this earlier, how to calculate the zeros, because we have to make this whole equation as a 0. So for that purpose we have to choose the numerator as a 0, means anything which is multiplied with 0, and in denominator whatever it may be, if in numerator it is a 0, this whole equation will become a 0. Okay, so this zeros will let you your equation to 0, equate to 0 by putting its values. So that's why we have got here s plus 6 is equal to 0, therefore we have got here s is equal to minus 6. So I think total 5 poles are there. This is 1 2 3 4 5 poles are there, and 1 0 is there. Okay, so let us see the pole 0 plot, that is third part. So as discussed earlier, this is the real axis, x-axis sigma values, real values. This is y-axis, g-axis, imaginary value axis, or j omega, that we have discussed earlier. So based upon our calculation, let us see first poles. So first pole is at a 0, second is at a minus 2, third is at a minus 3, fourth is at minus 4, and fifth is at a minus 5. But see here, we don't have any imaginary values here because there is no any j part, so that's why it will be on real values but on negative side, and one is at a 0. Okay, so as per that we know that poles are represented with a cross. So here first pole is there, g at 0, then second pole is at minus 2, third is at minus 3, fourth is at minus 4, and fifth is at a minus 5. Okay, so based upon that, similarly if you see the 0 is having the value as s is equal to minus 6, and as there is no any j omega part here, so that's why I can say that this is again a real value but negative side to the real axis. Okay, so that's why the 0 is represented by this circle, and it is at minus 6, is equal to minus 6 based upon our calculation. And finally we will get this plot, or s plane, or a pole 0 plot, okay, of a given transfer function. So such type of examples are asked in exam. Okay, so every we can say every question will be having, or every part will be having 2 marks, so it may be asked for 8 marks also. Okay, so these 3 things we have calculated. Now we have to move towards a very simple part of this given transfer function, that is calculation of a characteristics equation. Let us see how to calculate the characteristics equation. Now characteristics equation can be calculated by equating your denominator to the 0. So we have to equate this denominator to 0, and it will be our characteristic equation. But one important thing is that you have to solve that, you have to multiply each and every values inside. Okay, so let us see how it is multiplied. I think it is very simple for you, but again carefully you have to do, because there may be missing of one term and you will get a marks as a 0 for that particular question. Okay, so here how it is multiplied, just see the simple multiplication. So these first 2 brackets are multiplied here. So if you see here, this first bracket is multiplied to second bracket. So here s into s, that is s square, s into 5 as a 5s, then 2 into s is a 2s, then 2 into 5 is a 10. So 2s and 5s become 7s. So s into first bracket, that is s square plus 7s plus 10, bracket complete. Second bracket is s square plus 7s plus 12 is equal to 0. Okay, then if you see the inside multiplication of this s into this one, so it will become s cube, s into s square, that is s cube, this s into 7s, that is 7s square, then s into 10 as a 10s. Okay, so this is the first bracket or para, and this is second bracket or second para, that is equal to 0. So again if you have to multiply this inside, if you have to multiply, it will be multiplied like this s cube will be multiplied to each and every term. Okay, then after that this 7s square will be multiplied to each and every term, then 10s will be multiplied to each and every term. So finally after doing all this multiplication, and after that the final value of this characteristic equation will be like this, that is s cube plus 14s raised to 4, sorry, s raised to 5 here, plus 14 into s raised to 4 plus 71 s cube plus 154 s square plus 120 s is equal to 0. Okay, so characteristic calculation of a characteristic equation is very simple. Okay, so what I suggest to you that just to take this equation and solve by your own and just cross check your answer with this final equation. Okay, but in characteristics equation, don't keep that equation as it is, because we have to take that denominator and we have to equate to that 0, and after that we have to multiply this, means we have to simplify this, all these things inside that. We have to multiply all these things inside, and after that we have to denote that equation with respect to power, highest power given in the equation as per your calculations. Okay, so highest power is s raised to 5. Okay, so just like this characteristic equation can be obtained. Okay, so let us see next example based upon that. Okay, so for the transfer function, given transfer function, that is TF is equal to CS divided by RS is equal to S plus 2 divided by S into first bracket S square plus 2S plus 2 into second bracket S square plus 7S plus 12. Okay, now here again we have to calculate here also poles, zeros, then pole 0 plot and characteristics equation, but the difficulty level is increased here, so I think you will understand about this. Don't worry about this, I will tell you how to calculate the values. So as per this equation, if you want to calculate the poles of this given equation, the poles can be obtained by equating a denominator with a 0. Okay, so if you take this denominator, the denominator is s into first bracket s square plus 2s plus 2 bracket complete into second bracket s square plus 7s plus 12. So we have to equate this equation to 0. So as per the definition of the poles, it is equated to 0, and we have to find the value of this s in such a way that this equation will become 0, so that this transfer function will tends to infinity. Okay, or equates to infinity. So the first choice is very first choice, that is very simple. I can put directly s is equal to 0 here, so that 0 into multiplication of all this thing will become a 0. So initially we will get a value as a 0. Okay, so this is my first choice, that is s is equal to 0. So I am taking directly the third bracket here, because it is very simple for calculation. We will see this bracket afterwards. So again, I think we have seen about this in previous example also. The factors will be what? Our separation will become like this: s plus 3, that will be a first bracket, and second will be s plus 4, right? And just like this we have seen in previous example. So here also we will get s plus 3 is equal to 0. We have to put, so it will become s is equal to minus 3. Similarly, I can put s plus 4, this bracket also is equal to 0, so that I can get the value of s is equal to minus 4. Again I am repeating, the replacement of this whole bracket will be what? S plus 3 into s plus 4. Okay, so directly I have written here. We have seen previously, that's why I have not written directly here. Okay, so we will get initially we will get the value of s is equal to 0, s is equal to minus 3, s is equal to minus 4. Okay, now why I have kept this bracket aside? Because can you please tell me the direct factors of this whole bracket? Okay, so it is not so simple. Okay, so that's why we have to use some mathematical steps or equations to calculate the factors of this. Okay, so let us see how to calculate that, and definitely directly we are not getting the factors, so there may be a high possibility that it may be having imaginary values. So let us see how to calculate that. So let us concentrate on this bracket, that is s square plus 2s plus 2. Okay, now the roots of this equation that we have to calculate, but there is a formula. Directly we can't do, because if you see the roots of this equation, that is s plus 3 and s plus 4. Okay, though here it is not possible directly because by doing simple mathematics it is not possible. You can check. Okay, so what is the next thing? That is, we have to use this formula. I think you have used this in mathematics. So minus b plus minus under root b square minus 4ac divided by 2a. But what do you mean by this a, b, c? That is very interesting, or you must know about this. Okay, so here the roots are given in this equation, and there are two roots. So first root is minus b. Here in out of this plus and minus, you have to take only plus for first root. Means what? Minus b plus under root b square minus 4ac divided by 2a. That will be my first root, and the second root will be minus b minus under root b square minus 4ac divided by 2a. That will be my second root. Okay, so means what? This plus and minus is given, so take only one sign here, and that will be a one root. Replace that with another sign, and it will be your another root. Okay, so but what do you mean by this a, b, c? That you must know, so I will tell you, don't worry about this. So if you see here, here the coefficient of this is 1. Okay, so coefficient of this is 1, means what? The a's value will be 1 here. So b's value coefficient will be this one, and c's coefficient will be this one. Okay, so if you see, again I'm repeating, this s coefficient is 1, that is a. This s coefficient is 2, that is p, and here c is a constant, that is a 2. Okay, so in this way I can put here the values. If I put the first values as a b minus 2, then plus under root 2 square means what? 4 minus 4 into 1 into 2 divided by 2 into 1. Okay, so you have to do this on a paper. You will get answer. Again I'm repeating, you can note down the values of this. A's value is 1 here because s square's coefficient is 1 here. B's value is 2 here because s coefficient is 2 here, and c is constant, that is a 2. Okay, so given here. So here you have to put the values, keep only one sign here for one root, either plus or minus. Okay, and after that, by doing this multiplication and the solution of this, doing this simplification of this equation, you will get two roots, minus 1 plus j, and s is equal to minus 1 minus j. Okay, so root of a minus 1, see, listen carefully, root of a minus 1 can be given by a j. That you have to keep in mind. Okay, I think you know about this j, root of minus 1 and all these things. Okay, so we have successfully calculated the value of a poles, and which are s is equal to 0, minus s is equal to minus 3, s is equal to minus 4, s is equal to minus 1 plus j, and s is equal to minus 1 plus minus 1 minus j. So how many poles are there? So these are 1, 2, 3, 4, 5. So 5 values we have calculated here. Okay, so I think it is clear to you now. Now to calculate the value of a 0, the zeros can be obtained by equating numerator with a 0. Okay, so s plus 2 is equal to 0. Okay, here, because if you see the numerator is s plus 2. Okay, so s plus 2 is equal to 0, so that's why s is equal to minus 2 here. We can put s is equal to minus 2, so that the equations transfer functions value becomes 0 here, and that is the definition of a 0. Okay, so here zeros are only 1, so s is equal to minus 2. The only one 0 will be there, and which will be real also, and which will be at minus 2. Okay, so see, only one 0 is there, and poles are 1, 2, 3, 4 and 5. 5 poles are there. Okay, so again I am repeating here, you have to go through this equation. Okay, how to calculate the roots of equation. Okay, that you have to keep in mind. So if you see the pole 0 plot, again it is very interesting. Let us locate first 0 here, because it is only 1. So s is equal to minus 2, so it is a real value, so minus 2 is there, so that's why I have located here. And let us locate the real values of poles first, and after that we will locate these imaginary value of poles afterwards. Okay, so which are the real values? The real values is s is equal to 0. So yes, it is located here, s is equal to 0. Similarly, s is equal to -3. So s is equal to -3. So here located the real value of this. Similarly, s is equal to -4. Okay, s is equal to -4. So yes, it is located here, s is equal to -4. And after that, let's take these imaginary values also. Okay, now it is combination of real and imaginary, I can say. So -1 plus j, if you see here, so real value is -1 and imaginary value is a j. Okay, so if you carefully observe this axis, so here it is a j, 2j, 3j. Okay, so the positive values we can say, and these are the negative values of imaginary axis, that is -j, -2j, -3j, -4j will be like this. Okay, but if you see here, it is -1 and plus j. So let us locate first real value, that is -1. So -1 will be here, and I can take this -1 for this x-axis, and this imaginary axis is a plus j. So by combination of this and this, somewhere I will get the pole number 4 here, and that is given by cross here. Okay, so I think you understood this. It's very simple. Similarly, if I see this value, that is -1 minus j, again I can see -1 will be located from this and -j will be located from this, and here I will get the last pole value. Okay, so pole number 5 I can say. Okay, so if you see here, these are the real pole values 1, 2, 3, and these are combination of real and imaginary. So here we can get the values. Okay, so I think it is very much clear to you how to calculate the pore zero plot and all these things. Okay, so now what is the remaining part in this equation? So that is denominator part is there, which can be used to calculate the characteristics equation. Okay, so this is your homework. I'm giving you time, just calculate this characteristic equation. We will see the characteristic equation, we will cross check your values and my answer in next lecture. So I'm giving you time to just revise all these things. Okay, because it is one way, again I'm repeating, that's why I'm giving you some time in the after lecture, so that you can make some points, you can make some notes. Okay, so just solve this. I will ask this in a next lecture, or we will see about this in a next lecture. Okay, so thank you very much. Let's meet in next lecture. Just complete this, we will discuss about this, and we will take one more example based upon this. Okay, so thank you very much. Let's stop here and let's meet in a next lecture.